Before we discuss how to find the margin of error E, let's talk a little bit more about the confidence level C. So C is a probability, and in the previous video, we saw that C is the area underneath the standard normal distribution in the middle, centered around Z equals 0. But what does that practically mean with an actual example? And you'll also see that in the future, we'll talk about some other curves, such as the T distribution and the confidence level associated with that. Let's look back at the example we used before. The average age of Brookdale students is between 23.1 and 29.1 years is an interval estimate for mu. What's missing in that example is a level of confidence. Let's just suppose we are 95% confident that the interval from 23.1 to 29.1 years contains the actual mean age of Brookdale students. What does that exactly mean to say we are 95% confident? Of course, it sounds better than saying, for example, we're 50% confident. That doesn't sound very confident at all. But what does that mean that we are 95% confident the interval from 23.1 to 29.1 years contains the actual mean age of Brookdale students? In order for us to answer this, we need to answer this question first. If we took another random sample of Brookdale students, would we be guaranteed to get an interval estimate from U of 23.1 to 29.1 years? So remember, the interval estimate is built off that sample mean. So the sample mean we got was 26.1. Again, this was just a made-up scenario. And we created the interval from 23.1 to 29.1, centered at that sample mean 26.1. And with, of course, a margin of error of 3. The distance between the point estimate and the ends of the interval is 3. The interval is built off of this sample mean here. If you took another random sample, would you be guaranteed to get 26.1 as your sample mean? You certainly would not. So if you got something else, for example, maybe you got 25.7, and then if we created an interval from there by adding 3 and subtracting 3 from 25.7, we'd get 22.7 to 28.7. This is a different confidence interval than this one is. We are not guaranteed to get the same confidence interval. Now, suppose we did this a bunch of times. You might have a whole bunch of different intervals. So what does it then mean for us to be 95% confident that our interval contains the population mean? Let's suppose we took 20 random samples of Brookdale students and computed confidence intervals for the population mean age. With the same margin of error, we'd expect roughly 95% of them to contain mu. So mu is right here. Mu is a parameter that we don't know. So we're computing confidence intervals, and we're doing it 20 times, so with 20 different random samples. In blue here, this is one of our confidence intervals. Here's another one, here's another one, here's another one, all the way through. So all of these horizontal lines are confidence intervals. Notice that this blue one here contains the mean mu. So that one contains the mean. So does this one. This one has it in there. Even though it's closer towards the edge, it's still in there. All the way down, the only one that doesn't have it is this one right here in red. So what we mean by a 95% confidence interval, if you take 20 samples, we'd expect roughly 95% of them to contain the population mean. And that would be 19 of them. If you were to go through, you would see that there's 19 blue lines here that contain the population mean mu. This red one, this one, does not. This is the meaning of the level of confidence C associated with a confidence interval. Let's look at another example. So suppose XYZ Cancer Center reviewed medical data and found a 99% confidence interval of mu is between 62 and 70, where mu is the mean age at which men develop prostate cancer. So of men that have prostate cancer, they developed a 99% confidence interval of 62 to 70. So the mean age is between 62 and 70. Of course, with 99% confidence, it's not guaranteed. They did not collect all the possible data. This is only based on a sample of data. So what does this statistically mean? 99% confident means that we are 99% confident that our interval of 62 years to 70 years contains the population mean age for men that develop prostate cancer. So it contains the population mean, I'll just abbreviate that as POP just to save a little space. It contains the population mean age of men who develop prostate cancer. So that's the precise interpretation statistically of what this means. Now, what would a layman interpret this to mean? Most people will not have a mathematically developed sense of what 99% confidence means. So to a layperson, basically they would just accept this to mean that the mean age of men who develop prostate cancer is between 62 and 70 years. So basically it's this statement without the 99% confidence, because most people don't know what that means. If you ask somebody to explain the previous slide, most people would have no idea how to do that. So basically they say the 62 to 70 years old contains the population mean age of men who develop prostate cancer. So I'm not going to rewrite this, but it's this thing without the confidence level. Now, a couple additional questions before we move into being able to actually compute margins of error. We don't just guess them however we wish. In the initial example with Brookdale student average age, I just made up an margin of error of 3. We don't simply do that and guess that. We have precise ways that we need to compute that. That's what we'll be going into in the next video. So before we do that, though, let's answer these two questions. What did they use as their point estimate for the mean age? So just reviewing this. So the confidence interval is 62 to 70. So when they did their computations, what was their point estimate for the mean age? What was X bar? Well, recall that is the center of this interval here. To get the center, we can find the average of 62 and 70, which is 62 plus 70 divided by 2, which equals 66. So their point estimate for the mean age was 66. Now, what margin of error did they get with their 99% confidence interval? Again, the margin of error is the distance between the center and the endpoints. It's the same both ways because this is the center of that interval. And the distance between 66 and 70 is 4. So the margin of error E in this scenario is 4. Let's now move into being able to compute some actual margins of errors and do some real-world problems.